Right, okay. So we're going to go a quick read through. Figure 20 shows a mechanism with two cranks, A, B, and C, D. Right. Immediately when you know you've got two cranks, you're going to have to set up 30-degree segments for two circles, okay? That rotates in opposite direction. End B of connecting rod BD is pin jointed at B. Okay, so that's a pin. Okay, so it can move on that circle, but there's no slot there. So it's restricted to being on that circumference the whole way around. With the end D free to move in a slot D. Is that correct? So D with end D free to move in a slot at D. So in other words, that rod can move in and out of that slot. Connecting rod BD is extended to, BD is extended to P. That's obvious where we're going to have to trace our Loci from, that little point there. They're going to tell us now. Draw the mechanism, then trace the locus generated by point P. The reason why I could immediately tell is because point P is a bit random to be out there. There's nothing, So that's why we need to generate point P as the Loci for one full revolution of the crank. Right, so we're going to go clockwise at the top, anti-clockwise at the bottom. Right, so here's an interesting thing. What is our constant length, always?
So it's the 152.
So have a look. Let's have a look here. Let's go back to the video. Let's go back to our video. Gents, have a look at the video. This will be part of them. So if we go to this video, tell me which is going to be the length that is constant that we're going to trust the whole time. The blue, the total list distance of the blue, correct? Okay, so we kind of ignore the point D. D is going to change. The distance from, in other words, the distance from D to A is going to, and D to P is going to change as we rotate this mechanism. Does that make sense, gents? Because there's a slot. So the distance we're always going to be referring to is, like I said yesterday, the constant distance is going to be B to P, which is a total of 152 is our constant distance. And basically we're going to run point from B through D at various rotations. So we're going to go set up two circles. We're going to go center to center being 100. So let's go set that up and then we'll continue from there.
So then you just go from...
No, it's 100. Yeah, 52 is the constant. 100 is the distance between center and center of the circle with a 35 mil radius for the circle, which is the crank arm length. So there we go. That's one crank. Okay, I'm doing this in construction. You can go put this in. You can see how they indicate this as a pitch circle diameter. So it's not just a circle, it's actually long, short, long, short. Okay, I'll go and do that a bit later. First, I'm just going to do this all as construction. So do the top as well with a 35 mil radius. Okay, you do the starting position. Remember, show the starting position as an outline. So it can be done dark. Right, we're going to go set up center marking across those two. See now, oopsie, that didn't work. Complete these center lines. Yes, we have to. Why? Because they're both going to go through a full what? Rotation, yeah. You will have some fixed rods that will rotate left and right, but that's, you'll see, that'll come later. Okay, center markings in place so that I don't have to do them later. Okay, so now I'm going to go divide these into 30-degree segments because they are cranks that are going to rotate. Right. Should.
1 point doesn't make sense, so.
We'll check through this. Okay. Okay, my starting points are going to be as follows, and I'm going to do those in outline detail. So that's going to be A and B is my starting point on the rod. So that's B, and that's going to be A. Right, we're going to do C and D over here at 30. C, that's D. Right, then a point that runs from there, tangential to D. I'm going to do that in construction, and then I'll measure it. Let me just get the positioning of it. Okay, it's going to have to go further than that. That was silly. Right, so we've got 152 for this. So I'm going to go 52 off there. Okay, that's 152, and that'll be point P, starting point for the Loci. So everything is in dark. It needs to be in dark detail. And we'll go do the center markings for the pitch circle diameter a bit later. All right. I'm going to label the segments according to their movement. So I'm going to say that B is 0. It's going to be 0 and 12, but we'll say 0. And we're going to go clockwise here. So I'm going to call it 1, 2, 3. This is all in construction. 4, nice and light. 6, 7, 8, 9, 10, 11, and obviously 12 and 0 are the same. Then we're going to come here. We know this goes what? Anti-clockwise. Okay, while the one moves clock, the other moves in the opposite direction. So we'll call that D. We'll call that 0. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 0 and 12. Okay. And now I'm just going to make sure that I arc the distance of B to P continuously through each corresponding segment, right? So in other words, I'm going to go from 1 through 1. I'll do it in construction. Nice and light, please, at this point. And what did I do yesterday? I got a master length. Do you remember? I used my compass. I set it up to that master length of 152. Is that correct?
Yes, sir.
Now I've got the arc done. I can go and draw the rod in place. Every segment it moves. So if one goes, we go 1 clockwise. Here we go, 1 anti-clockwise. So from 1 through 1, and then all I'm going to do is arc that distance along that line there. See that? So I went from 1 through 1. Happy? Does that make sense? Can you see that? And then I arc the distance of 152. 152.
From 1 to the road.
Yeah.
So it's like 9 and 10.
Yeah.
I will say you got different.
Yeah.
1 to 1.
Yeah, so
Because he started at 0, so he started at 0.
So there's 0 through 0. That's 1 through 1. And that's
2 straight vertical line.
152.
So 2 to 2 is a vertical line. Yep, so it started at 0.
2, that's a straight line, obviously. Right, and we're going to go the distance that is required, which is 152. So from 2 through 2 is there. So 1 and 2. Then we're going to go 3 through 3. This will have symmetry with 1, surely. There we go. So there's 3. Then we're going to go 4 through 4. Right, so then we're going to arc that same distance. Again, and we just keep applying this principle all the way through. 4 through 4, 5 through 5, 5 through 5, okay, 5 through 5, and then we're going to do the same distance. There's 5, 6 through 6, keep going, same process. Arcing the total distance of the big rod arm. Don't think I've extended that enough to get a good intersection, so I'm going to do so. So there's 6, 7 through 7.
So my 8 through 8 is my first.
Right, so we've done 7 through 7 with the distance we need. Mine's also going to be quite close to the end of the page. 7 through 7 needs to go longer. Yeah, not a long enough reference. 7, 8 through 8. It's a straight line. Just going to extend that for reference sake. This is going to probably go a little bit longer. Oopsie. Than I initially anticipated. So I should have started a bit further at the top. Remember, you'll get a starting point in an examination or a control test. Okay. 8 through 8 is going to be, it's right at the bottom of the page. So my 8 is going to be over there. 9 through 9. Just skip a few ahead. 10 through 10. Okay, 11 through 11.
Anything about the sections is repetitive.
That is a very repetitive section. Right, so where did I end? I ended on 10, so now we're going to go to 9, arc, 10, arc, 11, arc. Right, so we're going to label those. We're going 8, 9, 10, 11. We can then go and draw the Loci, which, like I said, is kind of like a peanut in terms of its shape. So going P to 1, to 2, to 3, 4, 5, 6 through 7, to 8 and 9, 10, 11. It's not a very nice way to finish off. And P. There we go. So you've got that sort of peanut. Alright, so that's it, gentlemen. Again, I didn't position this very well, so I did miss out 8 just a little bit, so it should be just below that point. But I think very simple. Okay, doubling up on the segmentations, one anti-clockwise, one clockwise, looking for that constant length all the time.